The following is the video solution from JSDT Solutions. Question 4 says, the diagram below shows a circle with center P and the equation, so this is the equation of the circle. The circle cuts the y-axis at points R and S, okay? And then we have RT is a tangent to the circle at R and cuts the x-axis at T. Okay, so notice that theta is this angle formed by the y-axis and this line. So 4.1 says, determine the coordinates of P as well as the radius of the circle. Okay, we have the equation of the circle. So given this, we need to ensure that it's put in the standard form of the equation of a circle so we can clearly see the center and the radius, okay, the length of the radius. So let's rewrite this x squared plus y squared. Let's just rewrite this first. And we need to ensure that everything with x is next to each other, because in order to put this back in the standard form of the equation of a circle, we need to complete the square on this. So we'll rewrite this as x squared minus 6x plus y squared minus 4y is equal to 12. And now to complete the square. So you're going to take these two terms, and you're going to complete the square on them separately. So this will be x squared minus 6x, and then you take the coefficient of x and you divide that by 2. So that will be negative 3. And you're going to add negative 3 all squared. And then we're going to do the same thing for this part. So plus y squared minus 4y, and then we're going to take the coefficient of y, which is negative 4, and divide it by 2, which is negative 2. So we're adding negative 2 and we square that. Now, this is an equation. So what you do on one side, you must do on the other side. You see that we have added by this number squared and this number squared. We need to do the same thing on this side. So on the right-hand side, we say plus negative 3 all squared and plus negative 2 all squared. Okay, and now we're just simplifying. You see, if you expanded these, right, they'll become a trinomial and they would factorize like this. So you're going to open a bracket, and inside the bracket, whatever was squared, you're going to put that in here. So that is the x and the minus 3, and then that is all squared, because it was going to factorize to x minus 3 times x minus 3, okay? If you, of course, squared that and you got that number, x squared minus 6x plus 9 factorizes to this. Okay, so that's the first part, and we do the same thing here. So we say plus, and we have y, and that is minus 2, and then all squared, and then this is equal to, and then we just add this. Okay, so that's going to be 9, and that's going to be 4, so they already make on their own 13, and we're saying plus 12, so that is 25. So it's equal to 25. Now it is in the standard form of the equation of a circle, and we can tell them the value of P, the center of the circle, and the radius. So P would be, it's in the form of x minus a all squared, a being the x value of your center. So this is 3, and then that's y minus b, so that is 2. That's the center, and the radius is, this is r squared. Okay, it's in the form of x minus a all squared plus y minus b all squared equals r squared. So that's the radius squared, meaning the radius is, the square root of this is 5. And there we go. So that is our answer. Moving on to the next question. Question 4.2 says, show that the coordinates of r is 0 and 6. Okay, so R is on the y-axis, okay? And it's on the circle, but it intersects the y-axis. So it's a y-intercept, meaning to find it, we can simply just make x equal to 0, okay? And it will be, well, they already told you to find it in this format, so clearly this is going to be helpful. So we'll take this and we're going to make y equal to 0. Of course, we'll have two y-intercepts, but we will choose which one is r. Okay, so we'll make x equal to 0 to find the y-intercept, and this is minus 3 all squared plus y minus 2 all squared equals 25. And so negative 3 squared is 9, and if you transpose that, 25 minus 9 is 16. Okay, so we can just say this is y minus 2 all squared equals 16. And then to solve for y, we square root both hand sides. But this is an equation, so you need to consider the positive and the negative solution. Therefore, y minus 2 is equal to positive or negative 4. Then transpose the negative 2, y is equal to positive 2 plus minus 4. And so y is either equal to 2 plus 4, which is 6, or y is equal to 2 minus 4, which is negative 2. Okay, so 6 or negative 2. Which one would it be? Clearly, this is the negative 2. And this is the 6, okay, because it's the higher one. Okay, so we're just going to conclude that R is the coordinates 0 and 6. And that is our answer. Okay, moving on to the next question. Question 4.3 says, determine the equation of the tangent RT in the form of y equals mx plus c. So RT. We only have 1 point on this. We have 0 and 6. And how do we find RT? Okay, it's a tangent, okay? It is a tangent, so we can just use the radius. So connect from P to R, and there we go, we have a radius. And remember, we already have the coordinates of P. P has the coordinates 3 and 2. So we'll just say this is 3 and 2. And then remember that the radius and the tangent are perpendicular at their point of contact. So we can find the gradient of the radius and then use that, using the properties of perpendicular lines, to find the gradient of the tangent. Okay, so let's get P and R down. Okay, so the gradient is, well, we don't really have to write the gradient formula. You can just go ahead and find the gradient of PR. So this is equal to y2 minus y1. I'll just start from the bottom here. So 6 minus 2 and 0 minus 3. 6 minus 2 is 4. And that is negative 3. So this is negative 4 over 3. And so if this is the gradient of the radius, then the gradient of the tangent, and it is RT, that is the tangent, would simply be found by saying, because they are perpendicular lines, you simply just switch the numerator and denominator. So that is 3 over 4 and still negative. Then you multiply this by negative 1. Okay, so it becomes positive 3 over 4. That way, if you multiply the gradients of these perpendicular lines, they give you negative 1. Okay, so we have the gradient of RT, and we also have a point on RT. We have R, 0 and 6. So let's find its equation, and R is already a y-intercept, okay? So you can just find it in the form of y equals mx plus c. So y is equal to 3 over 4x, and this is a y-intercept. So C is 6 plus 6. And that is our answer. Okay, moving on to the next question. Question 4.4 says, determine the size of theta correct to 1 decimal place. Okay, so let's look at theta. Theta is on this line, okay, TR. It's really formed by it. But here's something we can do with this. So this is 0 and 6. We have theta over here, and we can actually just draw an imaginary x-axis. So this is just a line parallel to the x-axis, so you can better understand how this angle was created. So you put it right at that point there. Okay, so change the color of it. Now you can see that, actually let me just remove this for now. You see, with this angle that we're looking for, it's created with a 90-degree angle and another angle. So if you go from the y-axis to this line parallel to the x-axis, that's 90 degrees. Then we'd have to figure out what exactly this angle is. This angle, okay, if you go from this line parallel to the x-axis to the line TR, that extension, you see that it's the angle of inclination of TR. And to find the angle of inclination of TR, okay, do you see that they are vertically opposite? Okay, the straight line, the horizontal line, and TR cross. And so this angle, whatever this is that angle. So this is the angle of inclination of TR. And we already have the gradient of TR. So we can actually find this, and then you just add 90 degrees to it. And that would give you the entire theta. This angle plus 90 degrees, because these are vertically opposite. Okay, so let's find that angle of inclination of TR first. We know that the gradient of this line of RT, TR, is 3 over 4. So we'll say tan theta of RT equals 3 over 4. And so that means theta of RT is equal to arctan 3 over 4. And let's go ahead and find this angle. Okay, and then we'll just add, yeah, I think at this point you can just, because it's going to round off. So I'll leave it like this and then just say that theta is equal to 90 degrees plus theta of RT. Okay, so theta is equal to, okay, just to avoid confusion, I'm going to still say 36.869. Okay, not rounding off yet, but then just add a 90 degrees to it. That's all. So take that and then add 90 degrees, and there we go. So theta is finally equal to 126 point. Remember they said round off to 1 decimal place. So that is 126.9 degrees. And that is our answer. Question 4.5 says, a vertical line is drawn as a tangent to circle P at Q, which is A and B, where A is greater than 0, and we need to write down the coordinates of Q. Okay, vertical line, it's drawn to the circle at Q, okay, where A is greater than 0. It's vertical, so it's a standing line. Okay, so a vertical line. So for it to be drawn as a tangent, it can't be this side because they said that A is greater than 0. Okay, so that X value of the point Q is greater than 0. So the only other place it could be a tangent to this circle would be here, okay, where A is greater than 0. The X value is positive. So what they're saying is we have this point Q and we have A and B, and so A is a positive value. So what is this point Q? Okay, so it touches the circumference of the circle. That's what we know. So that simply just means that, you see, if it touches the circumference of the circle and it's a vertical line, right, it will be perpendicular to the radius, which is a horizontal line, okay, because this is a vertical line and the radius and the tangent are always perpendicular at their point of contact. So it's perpendicular to this horizontal radius, meaning if this is 3 and 2, okay, the X value is 3, it means that we know that the radius of this circle, we already found the radius, that was 5 units, right? R is equal to 5. So it means that we went from 3 and we went 5 units to the right to get to Q. And so the X value, A, is 8, okay, because 3 plus 5 is 8. And the Y value, it stays the same really, because this is 3 and 2. This is a horizontal line, so they share the same Y value. So this is 2, meaning, there we go, that is 2. Okay, P has the Y value of 2, and so does this because it is horizontally in line with Q. Okay, so this is 2, and so the coordinates of Q are 8 and 2. And that's our answer. Okay, we can just tell them Q is 8, and there's not really any calculation. The only calculation is that A, saying that we get that by saying 3 plus 5, which is 8. Therefore, Q is 8 and 2, and that is our answer. Moving on to the next question. Question 4.6 says, for which values of K will Y equals positive 3 over 4x plus K be a secant to the circle? Okay, we already had this equation. This was the equation of the tangent. So not really the equation of the tangent, but yes, it's the gradient of the tangent. So they want to find out for which values of K will this line be a secant to the circle. Okay, so when that equation Y equals 3 over 4x, okay, 3 over 4x is a tangent, this is where the K value is equal to, so that's the equation of the tangent, okay? So where the K value is equal to 6. So when we have the K value equal to 6, it's a tangent, but we need to find the values of K for which it will be a secant. Okay, let me just remove these because they don't really seem necessary. I'll leave the points, but we don't really need these. Okay. So to find out for which values of K it will be a secant, let's redraw this line and just see. So you see, if you take this line and it has that same gradient, we just need to see where it will be a secant. The minute you move it below this point over here, okay, so where k is equal to 6, the minute you move it below 6, where that y-intercept is lower than 6, it becomes a secant. It's intersecting the circle, cutting through the circle at 2 points. So there, it's a secant, keep being a secant until it gets to this point over here. So we need to find out where does that happen. And we need to ultimately find out what exactly the y-intercept will be at this point, because we're trying to find out the values of k. Okay, and k is that y-intercept. So we need it to get to this point, and let's see how we can find this. Okay, we can do this in the same way we found the equation of the tangent. Why don't we just extend this radius? Extend it to this point so it becomes a diameter. And then we can find out where it intersects with this tangent, because this is the tangent we'll focus on. And we can find out this point simply by using midpoints. We know what r is. R is 6, 0, and 6, right? And this is the other endpoint of the diameter. So we can just use this and find this endpoint. So I want to find out what exactly this point is. And so I'm going to use midpoints. Okay, so the midpoint formula, we're just going to go ahead and we already have the midpoint. So we're just saying we have this is x1, this is x2. I'll just take this as x1 instead, and that's x2, and that's y1, and that's y2. So, okay, we've labeled them, and now we can just say x plus 0 over 2, and then y plus 6 over 2. And this midpoint is equal to this midpoint that we already have, that center of the circle, which is 3 and 2. So we're just saying that's just going to be x. X over 2 equals 3, and y plus 6 over 2 equals 2. Multiply both hand sides by 2. X is equal to 6. Here, multiply by 2. Y plus 6 equals 4. Y equals 4 minus 6, which is negative 2. So this point is 6 and negative 2. Great, we have this point. Okay, so 6 and negative 2, we have this point now. We know what this is. So why is this important? Because it will find the equation of this line, the tangent with this same gradient, but that is a tangent to the circle at this point. And this is the last place it will be a tangent to the circle. If you move it anything further than this, it no longer intersects, okay? And if you move it above this, it will be a secant. So we need to ensure that whatever that y-intercept is, okay, whatever that value is, k just needs to be anything above that, but anything below 6, and then that will make this a secant and not a tangent. Okay, so now the goal is to find the equation of this. We already have the gradient of the tangent, so we don't even need to use this gradient. So the gradient of the tangent is already 3 over 4, and we have to find out what the equation of this line is so we can find that y-intercept. Okay, so the gradient is 3 over 4, and we're saying y minus y1 equals m times x minus x1. And so the x1 and y1, this is the point on that tangent. So this is y minus negative 2, which becomes a plus 2, is equal to 3 over 4 times x minus 6, equal to, and we'll say 3 over 4x. And then if we multiply here, 3 over 4 times negative 6, they have 2 in common, so divided by 2 is 2. Divided by 2 is 3. So this is negative 9 over 2. Okay, negative 9 over 2, and then transpose the 2 minus 2. So y is equal to, the equation of that tangent is 3 over 4x. And we can just say negative 9 over 2 minus 4 over 2. So that's going to give us negative 13 over 2. Okay, so negative 13 over 2. And that is that y-intercept. So here's what we're saying about k. This will intersect again here at negative 13 over 2, right? And for this to be a secant, then k, that y-intercept of the tangent, should just be anything that is above negative 13 over 2, but nothing beyond this y value of 6, because if it goes beyond, it no longer intersects, and we can't even call that a secant. Okay, so that's what it needs to be. K must simply be greater than, so we'll say K needs to be greater than negative 13 over 2, but less than 6. And that is our answer. Okay, so that is it for this question. Moving on to the next question. Question 4.7 says, another circle M with equation x plus 3 all squared plus y plus 2 all squared equals 36. Okay, it looks a lot like the circle that we have, but the radius is 36. Okay, so this circle is drawn, and the question is, will circle M touch or cut P, or will it neither touch nor cut circle P? Okay, show all calculations to determine your answer. Let's just speak about how circles, intersect or don't intersect, or intersect at 2 points. So if you have two circles and they intersect, let's just say they intersect at 1 point only. What's going to happen is you'll notice that if you calculate the radius of the one circle and you add it to the radius of the other circle, so the distance between them would be exactly the same as the sum of their radii. Okay, so that means it intersects at 1 point only. Now, if these circles were to intersect at 2 points, okay, so we want to see an intersection here and here, then look at the relationship between this distance between their centers and the radii. So that distance, right, if you connect that, do you see that that would be shorter than the distance between, or the sum of their radii? Because you're going to add from there to that circumference, from here to this circumference, and so that is going to really just be shorter. So the distance will be less than radius 1 plus radius 2. And then if the circles do not intersect at all, then you will see that the distance, as you can see, that's much larger now. The distance between their centers would be greater than the addition of their radii. Okay, so the distance will be greater than radius 1 plus radius 2. That's all we need to focus on. Okay, so let's go ahead and find this. Okay, so let's look at each circle. So we have the circle with center P, and its points are, okay, we had 3 and 2, and we knew that the radius was 5. And then the circle with center M that we have here, the center is -3 and -2, and we can see that r squared is 36, meaning the radius itself is 6. So let's find the distance between their centers, and then we'll add the radii. Okay, so using the distance formula, we just say the square root of x2 minus x1, so I'm just going to say -3 minus 2 all squared plus -2 minus 2 all squared. Okay, let's see what we get. And we get the square root of 41. And then you can also just put this in decimal form. So it's 6.403. Okay. And we're going to compare this with adding the radii. So take the radius of the circle P and add this to the radius of the circle, the center M. We get 5 plus 6, which is equal to 11. Okay, so you can see that the distance is less than the addition of the radiuses. So P plus R with M. Okay, we can see that 6.403 is a value less than, we can just say PM here so they know. Okay, it's a value less than 11. So what does that mean? Okay, if your distance is less than the addition of the radii, it means they intersect at 2 points. Okay, so they intersect at 2 points. So you can actually just conclude that, yes, they will intersect at 2 points. Okay, so in conclusion, circle M will touch circle P at 2 points or twice. Okay, and that is our answer. And that is it for question 4.